second. So now this one. I've got this paper and it says the first question. This first concept paper. This one is so this one is summer 1913. Okay, just doing an MCQ paper. Otherwise, we're doing paper 2s. The first question is manganese and nitrogen can show a range of different oxidation states. Calculate the sum of the oxidation states of Mn and N in each row of the table. In which row is the sum the smallest? So over here, I think sum ki baat kar raha hai. So this is +4 and N is 0. So the sum of the oxidation states of Mn and N. So yahan pe kya total sum is going to come out to be +4. Mn over here is +2. And N over here is yahan pe kya hoga? What it's going to be? It's going to be +3. But it wouldn't nikalne aani chahiye. NO2 -1, so it's going to be X. Oxygen is -2. And there are 2 of them, and the total charge on the whole thing is -1. So it's going to come out to be +3. So yahan pe it's coming out to be +5 total charge on Mn and N. So what is yahan pe K2MnO4 -1? Sorry, K2. What's the formula? K2MnO4. Sorry. Okay. That's a K2MnO4. So now when it comes to oxidation states, make sure you treat ionic compounds as 2 separate ions. K ka pata hona chahiye, it's +1. So what would be the charge on MnO4? Because there are 2 Ks. So over here it's going to be -2, right? Is that clear? So what I'm going to do is I'm going to try and solve MnO4 -2 separately. But +6 hoga. Okay, Mn is X. This is -2 times 4. And the total charge on the entire thing is -2. So X comes out to be +6. So Mn over here is +6. N over here is, I think, -3. Because H +1 hai, so there are 4 of them. So tab jaake the total charge would come out to be +1. So yahan pe it's coming out to be, the total charge is coming out to be +3. Sum of the oxidation states. Mn over here is +3. And what is N over here? You would have to find that. It's X. Hydrogen is +1, so into 3, and there's 1 oxygen. And the total charge on the entire thing is 0. So what is this? This is 3 - 2 is, what is 3 - 2? That's +1. X would, I think, come out to be -1, right? Yes, it's coming out to be -1. So over here, the total charge is coming out to be +3 - 1, that's +2. So B, I guess, is the correct answer. So, make sure you, like if you have a compound of NH4NO3, right? Always when you're trying to figure out oxidation states, always try to treat the ions as separate species. Ke isko alag solve karo, NH4 +1 and NO3 -1 has to be solved separately. Both ends have different oxidation states because they're 2 completely different. They're 2 completely different ions. ठीक है, ये बस एक चीज, उसको इकट्ठा solve करने की कोशिश ना करना, ठीक है? Just make sure don't do that. Now, moving to this, 1 second. अच्छा, smallest था, फिर मैंने गलत किया. Some of the is, the smallest, you're right. D is the answer. ठीक है, that's fine. I didn't see this thing. Okay, smallest. He was asking for the smallest. I said now this one. You have a mass spectrum of an alloy of copper and gold, and it's shown which expression can be used to calculate the relative atomic mass of copper present. So remember, this is an alloy of copper plus gold. And how do you calculate AR? AR is calculated if you just sum up the percentage abundance of the isotope multiplied by the isotopic mass. And you're going to divide it by 100 because you're looking for the fractional percentage. Now over here in this question is slightly tricky because remember, he's talking about copper. He's asking you to calculate the AR of copper. So this gold must not be, this is gold. Gold is, if you look at the periodic table, that's 197. So you don't include gold in your calculation. So the calculation would be done. This is copper. Copper is 63, or there's another isotope of copper, which is 65. So how do you calculate AR? It's going to be the percentage of, let's say one of the copper has a mass of 63 multiplied by its percentage. So what is the percentage of this copper? That's 56.36, but it's going to be divided by not 100, because if I remove gold from the composition, though 100% is, I mean, this is 100% included gold. So I'm going to exclude gold, 18.5%. So the total percentage composition is 56.36. So that is 56.36 plus 25.14.
81.5.
So that's 81.5. Make sure, because remember, the percentage must be of copper only. It should not include gold in it. So you would have to exclude that. So the fractional percentage would be 56.36 out of the total percentage, which is 81.5. And the other isotope is 65. And that's going to be 25.14. And that's going to be divided by 81.5. Is this clear? I mean, the trick to this question was it should not have been out of 100. Just like I wrote the formula out of 100. It's not out of 100 because you're going to exclude gold from the percentage. So the answer to this one is going to be so 81.5. So I think it's this one. It's C. So this yahan pe. So this is exactly the same as C. Is this clear?
Yep.
An atom has exactly 3 unpaired electrons. By just without even writing the electronic configurations, you have to be quick. Which group does it belong to if it's got 3 unpaired electrons? What's the electronic configuration of group 1?
Group 7. S1.
Group 1 is S1, group 2 is S2, group 3 is. तो वो कहाँ पे जाके आएगा 3? Group 3 is S2P1, right? So it's going to come out to be group 5, right? It's going to be S2 and P3. So it's an atom that belongs to group 5, which is going to be phosphorus. I mean, you can have a look at the electronic configuration, 15 electrons. So it's 1s2, 2s2, 2p6, 3s2 and 3p3. So वो outermost वही आ रही है, ठीक है? It's S2 and P3, ठीक है? So remember the shortcuts. Don't waste time writing the whole electronic configuration. So the next one is, which element? So you've got element W, and it's in period 3 of the periodic table and has a solid white oxide. Now this is inorganic, okay? And also let me open up the inorganic notes. It's a white solid, is thermally stable and has a very high melting point. So it's in period 3. So who has a very high melting point? It's got a white oxide and it's a stable oxide and it's got a very high melting point. Plus the oxide, X is the oxide, right? The oxide also happens to be slightly soluble in water. So which element is this? If I
Mg.
Okay, so this is Mg. If I open the notes, this one is Mg. I mean, definitely Mg, because MgO, remember, has an extremely high melting point. It's often used as a ceramic, and it's a white solid, group 2 metal compound. It's a white solid. It's thermally stable. Plus, it's very, very slightly soluble as well. So the structure of X, it's going to be a giant ionic lattice, strong ionic bonds, giant. Which one is the correct? I mean, this one is wrong because it has ionic bonds, but you don't call something that has ionic bonds as molecules. So C is the correct one. That's a giant 3-dimensional ionic lattice. You've got other oxides also which have high melting points, but they're not soluble. Aluminum oxide, silicon oxide, but they're not soluble in water. Now this one, he's saying that they have the same number of electrons in the molecules. Their boiling points are. This one has a higher boiling point. What could be the reason for that compared to the first one?
hydrogen bonding.
It doesn't have hydrogen bonding. क्योंकि hydrogen bonding के लिए what do you need? You need fluorine that is directly bonded to H. Over here it's bonded to carbon. It's just polar that it's got permanent dipoles. It's a very polar molecule, but not hydrogen bonds. So it's got a higher boiling point. So I think that's going to be B. The other one is non-polar. It's got van der Waals forces only. It's got no dipoles. Carbon and hydrogen bonds are non-polar. As the next one, which statement is correct? There's an energy profile diagram. The activation energy of the forward reaction and the enthalpy change of the backward reaction have the same sign. No, they don't, because activation energy for the forward reaction is this one, and the enthalpy change for the backward reaction is this. For the backward, you start at this point, you end at this point, so that's the enthalpy change. So the first one is wrong. फिर अगला, the activation energy of the forward reaction is more than twice the enthalpy change of the backward reaction, and opposite. That kind of looks fine. Okay, the activation energy for the forward reaction, there are 4 lines, and the enthalpy change of the backward reaction, that's two divisions. So it is more than twice, and they do have opposite signs. One is gaining, the other one is losing. So that's that looks fine. और बाकी फिर probably गलती होंगे. They don't have the enthalpy. Wait a second. The enthalpy change of the forward reaction. C also looks good. एक second, क्या मस्त है? More than twice the enthalpy change of the backward reaction. That makes perfect sense. What's wrong with C? The enthalpy change of the forward reaction. Okay, sorry, he's talking about the enthalpy change. What's wrong with C is that the enthalpy change of the forward reaction is this. You start at this, you end over here. And the activation energy of the backward reaction have the same sign. The enthalpy change and the activation energy of the activation energy is always endothermic. So C is also correct.
Sir, B is not more than twice. It exactly twice.
अच्छा ठीक है, I didn't see that. More वाला देखा ही नहीं है. ठीक है, so again it was just a silly mistake. B is wrong. Not more than twice, it's exactly twice. ठीक है. So C is the right one. What changes in conditions or molecular properties make it more likely that gases approach ideal behavior? So when do gases behave as ideal gases? When does anything behave as a gas? What conditions would suit it?
High temperature, low pressure, and weak intermolecular forces.
Okay, so anything would basically behave as a gas if it's got very weak intermolecular forces. Or the two main assumptions are that anything would behave as a gas at high temperatures, because you can then easily overcome or break the intermolecular forces. Or low pressures, because at low pressures, particles would be so far away from each other that the intermolecular forces, because of the distance, would automatically become weak, and it would start behaving as a gas, and the particles would start moving freely in all directions. So these are the two conditions, and those two conditions are basically to overcome the intermolecular forces. So if it already has weak intermolecular forces, it will behave as a gas. Now, ethanol can be oxidized to ethanol by this dichromate 6, oxidation reaction, reduction. Which equation is correct? Now, when you want to balance or write an equation, one of them is an oxidation equation, half equation. The other one is a reduction equation. The first thing you have to do is you have to balance the number of electrons gained and lost. So for that, I'm going to multiply the first equation by 3. So this would become 6. And this would become 6 electrons as well. So the electrons gained and lost are equal. The second thing is you add up the reactants. So the reactant in the first one is 3 C2H5, which the other reactant is Cr2O72 minus, and there is 14 H plus 1. The electrons are going to get cancelled out. And in the product side, you have 3 C2H4O. And there is 6 H plus 1 as well. And there is 2 Cr3 plus in the bottom equation on the right hand side, and there's 7 H2Os. Now, a few things would get cancelled out, like the 6 H plus 1 will on the other side go, and they will become 8 H plus 1. So option A looks to be correct. So that's your equation. What is the correct expression for Kc for the reaction? That's easy. Products over reactant. So it's I-1 squared. So this one, Fe3 plus products, the coefficient becomes the power. So it's this one. So B is fine, I think. Yes. Now X and Y react together to form Z in a reversible reaction. So X and Y are reacting and they're forming Z. We don't know what the coefficients are. The equilibrium yield of Z is lower at higher temperature. So if it's lower at higher temperature, is it endothermic or is it exothermic?
Exo.
It's exothermic because exothermic reactions are not favored at higher temperatures. So it's either going to be A or it's going to be C. So the forward reaction is probably exothermic. There's less Z getting formed. And the equilibrium is lower at lower pressure. Lower pressure कौन सी side को favor करता है?
More number of moles.
ठीक है, more gas moles specifically. ठीक है. So he's saying that there is less Z. So more gas moles would be on the other side. So it's going to be A. Like if I lower the pressure, more gas mole side would be favored. More gas mole side is the backward reaction. Because 2 molecules of gas are going to be produced. So which is why the amount of Z produced is going to be lesser. ठीक है, ये clear है question? Yes or no?
Yes, sir.
अच्छा, अगले पे आ जाते हैं. We've got volume of carbon dioxide collected by reacting 0.1 mole per dm cube, 0.1 mole of magnesium carbonate with 50 cm cube of 1 mole per dm cube sulfuric acid against time. The volume produced is plotted against time, and the line labeled P on the graph is obtained. So this is the reaction that's happening. इसके साथ. So the experiment is now repeated using 0.1 moles of the same magnesium carbonate. So they're not changing magnesium carbonate. And a different sample of acid. All other conditions remain the same. Plotting these results gives the line above. So what sample of acid could the line label Q? First thing, is Q faster or slower?
Faster.
Slower.
Slower. Its steepness, now the steepness is, it's less steep. I mean, P finishes much quickly. It's more steep, right? Is that clear?
Yes.
Okay, this is slow. So what does that mean? Is the acid in the second experiment in Q, is it going to be more concentrated or less concentrated?
Less.
Yes, so it's going to be less concentrated. So the concentration would be less than 1 mole per dm cube. Because जो पिछला part था ना, over here, the concentration was 1 mole per dm cube, but now the concentration, because it's a slower reaction, it's going to be, so it's either going to be 0.5 mole per dm cube, 0.5 mole per dm cube, but not 1 mole per dm cube, because तब वही speed होती है, it would have been much faster, ठीक है? अच्छा, so it's either A or C. Second thing, there is a lot more Q forming. So that means there's going to be more moles of acid. Isn't there's more reaction happening, right? So how many moles did you have initially? Initially you had, like originally you had, how many moles you had? 50 times 1 divided by 1000, right? So how many moles do you get?
0.05.
So you're getting 0.05 moles. Now you can see that the amount of gas has doubled. So that means although you're using a more dilute acid, but the moles of acid are going to be double because other gas burn here. So there's going to be a lot more Q that's going to be formed. So 0.05 moles, so by just looking at it, it should be, the amount of acid must be double the amount, so 0.05. So it should be greater than 0.05. So this is 100 into 0.5. This is exactly 0.05, right? तो इसके अंदर तो वही amount बननी चाहिए. The amount of gas produced would be exactly the same. So C is going to be the answer. Because over here, the moles of acid would come out to be 0.1 moles. I mean, 0.5 into 20. And
सर P ज़्यादा steep क्यों है? सर मतलब concentration इसकी ज़्यादा है इसीलिए?
नहीं, पहली बात है P ज़्यादा steep है ना, वो तो ग्राफ से नजर आ रहा है ना. क्लियर है? मतलब P की
जी सर.
तो इसका मतलब है P faster है ना, P reaction faster है. So why is P faster? जब उसने same conditions use की हुई है. So P is faster because उसकी concentration ज़्यादा होगी ना.
जी सर, ठीक है.
तो I knew कि Q जो है वो slow है. Q is slow, so that means the concentration of Q would be lesser than this one. लेकिन फिर था कि वो the amount of gas that is being produced is double the amount. So that also kind of indicates that even though the concentration is less, but there's a lot more Q. ठीक है, इसलिए ज़्यादा gas बन रही है. So it's going to be C, that it will have a lower concentration compared to 1 mole per dmq, but there's going to be a lot more of the acid. Because at the end of the day, there's a lot more gas that's being formed. ठीक है, is this question clear?
Yes sir.
So next one, sodium and sulfur react together to form, this is easy, like the atomic radius. So is sodium bigger or sulfur bigger? What happens across the period?
Atomic radius will decrease.
ठीक है, sodium and sulfur, atomic radius decreases because they both have 3 shells, because they're both in period 3. But sodium has 11 protons, nucleus mein, and sulfur has 16 protons. So sulfur is going to attract those electrons with a lot more strength. So it's going to be a lot smaller. Sodium is going to be bigger than sulfur. So it's either going to be C or D. What about the ionic radius? What happens to sodium's ion? Is it smaller or is it bigger? And what happens to sulfur's ion? Ion ko kya hoga? When sodium forms an ion, what does it do? It loses a shell.
Sodium will be smaller because it is a cation.
Because it's only going to have 2 shells, right? Because it's going to lose its outer shell. 281 tha, so the outer 1 electron is gone. And so when sulfur forms an ion, it actually gains electrons. So which is why it's going to be bigger in size. So the answer would be D. Remember, when it comes to negative ions, they increase in size because they gain electrons, and positive ions, they decrease in size because they end up losing electrons. As a next one, you've got which graph represents the variation in electronegativity for period C elements. So electronegativity across the period, what happens? What is the correct graph? Across the period.
So it increases.
Okay, so it's going to be B. It increases to the right. Now this one, dilute hydrochloric acid is added to solid barium carbonate, magnesium carbonate in separate test tubes. Dilute sodium hydroxide is added to barium chloride and magnesium chloride in separate test tubes. Which row is correct? Now this is, as I remember, your test for cations and anions. Okay, you have to, even most of you are not actually यहाँ पे कहीं था, एक second. Even most of you are not giving ये जो practicals है, but यहाँ पे the tests are copied. Okay, so you should remember the test. It's O-levels tests of cations and anions. How do you identify a carbonate gas? So this is also part of inorganic. You have to remember this as well. So the first part is you've got what will happen? Barium carbonate with HCl. There's going to be a reaction. and barium chloride, which is a soluble salt, it's going to be produced, and water and carbon dioxide would be produced. So you're going to see effervescence. So all three are correct. When you react magnesium carbonate, same thing would happen. Magnesium chloride, which is a soluble salt, and water and carbon dioxide would be produced, and you're going to see effervescence, bubbles of gas. So what happens when barium ions are added to NaOH, and what happens when magnesium ions are added to NaOH? So
White
what's
precipitate.
for magnesium, it's going to be a white precipitate. Why? Because magnesium hydroxide, when the magnesium ions and the OH ions, they get together, though MgOH2 is insoluble or partially or slightly insoluble, so it's going to form a white precipitate. When barium does the same thing, barium hydroxide is soluble. So if it's soluble, there's not going to be any change, no precipitate formed. So hence the answer is going to be C. ये याद रखना कि group 2 के अंदर the solubility of the hydroxides, what happens? Where's the hydroxides? So solubility of the hydroxides. The first one is less soluble. The bottom three are more soluble. Calcium is also partially soluble, but the bottom two are very, very soluble. As a river water contains these ions in water. In this water is treated by calcium hydroxide. What is the precipitate? What is precipitated from the river water when calcium hydroxide is added? So what precipitate would form? Precipitate is an insoluble thing. And there's only one thing that is insoluble, and that's calcium carbonate, because chlorides are soluble. Nitrates are all soluble. Hydroxides, NH4+1 compounds are all soluble. So it's the only option is calcium carbonate, because calcium ions and carbonate ions in the water would combine to form a precipitate. Okay, the next part is the solid sodium chloride and sodium iodide both react with concentrated sulfuric acid at room temperature. The NaCl produces this thing and the NaI produces all of this. What is the explanation for this difference? So this is again a very typical question about group 17. Remember what happens in group 17, that for halide ions, the bottom ones are very good reducing agents. They really like to lose electrons. I-1 is bigger in size, Br-1 is bigger in size, so they really, really like to lose electrons. ये दोनों electron lose नहीं करना चाहते. F-1, Cl-1, they're very electronegative. They don't like to lose electrons. So the bottom two get easily oxidized, and they're very good reducing agents. So what happens is when you add NaCl to H2SO4, which H2SO4 is an oxidizing agent, but Cl-1 does not like to lose electrons. It doesn't like to lose electrons. It's a bad reducing agent, so no redox reaction happens. The only thing that happens is that the ions, when they mix up in water, when you mix up H2SO4 and NaCl in water, the H+1 and the Cl ions might combine to form HCl gas, and you would see white fumes of it. So there's going to be a displacement reaction, but no redox. But as you move down the group, I-1 and Br-1, they kind of do the same thing. Like I-1 combines with H+1 from the acid, ends up forming fumes of HI, but I-1 really likes to lose electrons. So instead, it also at the same time simultaneously starts to lose electrons, and that results in the formation of reduction products, because I-1 is a very good reducing agent. So what is the explanation for this difference? Chloride ions will displace iodine. No. Iodide ions are better reducing agents. So C is the option. That I-1 really likes to lose electrons. It's a very good reducing agent. Clear?
Yes, sir.
The other part is the aqueous solution of calcium compound is treated with a mixture of ठीक है, ये मैं भेज रहा हूँ, एक सेकेंड. इसी में चैट में इसका लिंक शेयर करो, ठीक है. अच्छा, aqueous solution of a calcium compound is treated with a mixture of nitric acid and silver nitrate. The resulting white precipitate dissolves with aqueous ammonia. So nitric acid and silver nitrate are basically tests for halide. And it's specifically a test for Cl minus 1. Like when you get a white precipitate, that is a specific test for Cl minus 1, which is given over here. For Cl minus 1, you get a white precipitate which dissolves in dilute NH3. So iska matlab hai the compound, calcium compound, is going to be calcium chloride. And you have to figure out the MR of this thing. So it's going to be 40.1 plus 35.5, and that's going to be multiplied by 2. So I think that's going to be C.
Yes, 111.
Okay. So which statement about the ammonium ion is correct? So ammonium ion is basically NH3. That has datively, it's got a lone pair. And ammonium ion is an ammonia that has datively accepted an H plus 1. The H plus 1 gets attracted to these lone pairs, and they form a coordinate bond. So it can act as a base. No, it cannot act as a base. The ammonium ion can act as an acid because it cannot accept more H plus 1, but it can release an H plus 1. So it can act as an acid, not a base. It can react with OH ions to give ammonia. That is true. B is true because if there's an OH ion, the ammonium ion can release an H plus 1. And when it does that, the ammonia is reformed. So that is true. It is not pyramidal because it's tetrahedral, 4 bonds. And the nitrogen atom is sp2 hybridized. When it's tetrahedral, that's sp3 hybridized, not sp2. So which is why that is also incorrect. Here, a catalytic converter, 5.6 grams of carbon monoxide reacts with excess of nitrogen monoxide. What is produced in this reaction? So what's being produced? So carbon monoxide, 5.6 grams. So how many moles is that? That's 5.6. We're going to try and figure out the ratio first. Can somebody calculate quickly? 5.6 divided by 12 plus 16, that's 28, I think. How many moles is this?
0.2.
As I said, 0.2 moles. And it's reacting with nitrogen monoxide, which is, that's an excess. So that's an excess. So what's going to happen is carbon dioxide is going to be produced and N2 would be produced, right? So if you have 0.2 moles, the amount of carbon dioxide would also be 0.2 moles. I think the equation is balanced. No, it's not balanced actually. You need to balance this equation. So if I do, I can just balance it by writing half over here. Do you guys, that's balanced now? That's 2 oxygens, 1 carbon, and there is half N2. So now it's balanced. So the amount of moles of N2 would be half of that. That's going to be 0.1 moles, right? And you have to find the mass now. So what's 0.2 multiplied by the MR of carbon dioxide? That's 44.
8.8.
Okay, so it's these two. And 0.1 moles of N2. So 0.1 moles of N2, 0.1 moles into the MR of N2, that's N2 is 28.
2.8.
So it's going to be D. I said next one. We're on organic now. Whatever this is, it occurs when NaI in propanone reacts with a chloroalkane or bromoalkane. The halogen is directly replaced by I. What did he mean? When NaI in propanone reacts with chloroalkane or bromoalkane. So whatever. So which halogenoalkane produces compound X? So NaI in propanone. I said So propanone is just a solvent. It's got nothing to do with this reaction. So that was what I was getting confused with. So NaI is dissolved in propanone and it reacts with chloroalkane, some random chloroalkane. And he says the halogen is replaced by I. So the halogen gets replaced by I. So before there was I, there must be Cl over here. And the reaction only works for primary halogenoalkanes. So which halogenoalkane produces this? So the halogen is directly replaced by I. So that is, I did the reverse. I replaced the I with the Cl back again. So what is the correct, and did he talk about chloroalkane? He did do. So which one is this one? That's 1, 2, 3, 4, 5, 6, 7 carbon atoms. It can't be, it's got to be D. TKD say it. Because there's a carbon atom, which is this one. It's got 2 CH3 branches, so those are the 2 CH3 branches. Next door, there's a CH2. Then there is a CH, and then there is another carbon branch, which is CH3. And then there is CH2 over here. So D is exactly what this is. You can draw it out if you're still confused. Like, you can start with this carbon atom, ignore the hydrogens. This carbon atom has 2 CH3s. Then there is a CH2 next door. Then there is CH and another CH3. And then there is CH2 and Cl. So this kind of looks exactly the same as this one. Okay, next one, what is the empirical formula of Y? So again, it's a skeletal formula question. It's carbon. So those are your 4 carbons. This one is going to have 1H. This carbon has complete 4 bonds. This one also has complete 4 bonds. So what's your formula? It's C4. H is 1, 2, 3, 4. And there are 4 O's as well. ठीक है, सही किया?
Yes, sir.
That's my next one. Polymer Z, every carbon atom in the polymer chain is bonded to 1 hydrogen atom and 1 methyl group. Okay. Which alkene could be polymerized to make polymer Z? So he's saying every carbon atom is bonded to 1 hydrogen and 1 methyl group. So it's probably going to be B. Like, if you would have to draw this out. Butene is this one. And there is H, and 3 H's with this one, and 3 H's with this one. Now, when you make a polymer, you don't draw anything on the right or left side of the double bond. So there's an H, another H. The CH3 on the right side will be bent downwards. The CH3 on the left side would also be bent downwards. And the double bond in the middle would go away, and this thing would be a repeat unit. So every carbon atom would be bonded to 1H and 1 methyl group. So B is the correct answer. ठीक है, ये clear है?
Yes, sir.
ठीक है. अच्छा, उसके बाद है, there's this which compound would produce this one second. Just hold on 1 second. So the next one. The next one is which compound would produce a carboxylic acid and a ketone when hot. Now, this is strong oxidation. So what is strong oxidation? In strong oxidation, the double bond is going to completely break. So the double bond is going to split over here. And this thing, so you got this carbon atom and you got this carbon atom. So if a carbon atom, once the double bond is split up, just hold on 1 second. So when the double bond is split up, if it's got 1 carbon chain, it turns into what compound during strong oxidation? What does it turn into?
Carbon dioxide and acid.
Okay, so if it's got 1 carbon chain, it turns into a carboxylic acid. And if it's got no carbon chains attached to it, the double bonded carbon atom, that will turn into a carbon dioxide molecule. So over here, he was looking for a ketone and a carboxylic acid. We got a carbon dioxide and a carboxylic acid. So this one, the double bond is going to completely break in the middle. So you'll have this section and you'll have this thing. So this carbon has one carbon chain, so this turns into carboxylic acid, and the other one also, this one over here also has one carbon chain, so that also turns into a carboxylic acid. So you got two carboxylic acids. This one will turn into two ketones. Like if you split this up, this one has two carbon chains, so that's ketone. This one has two carbon chains, that's also a ketone. So the last one is then the correct one, because you break this up into two pieces. This one has one carbon chain, so that turns into carboxylic acid. This one has two carbon chains, so that turns into a ketone. So D is the correct answer. And let me open the so D. Moving to the next one, water is added to a sample of 2,3-dibromohexane. First thing, 2,3-dibromohexane, what is that? That's 6 carbon atoms, hexane. And it's 2,3-dibromo, so bromine over here and bromine over here as well. So this is the molecule that we are talking about, undergoes complete hydrolysis, and some of it undergoes partial hydrolysis. What is not present in the mixture of the product? So complete hydrolysis means both of them get replaced by OH. Partial means one of them gets replaced by OH. The conditions for this specific reaction, this is a halogenoalkane, remember, gets hydrolyzed by NaOH aqueous, and you reflux it, it turns into an alcohol. The halogen would get replaced by OH ions. So that is what hydrolysis is. So what is not present in the mixture? So either both of the BRs are gone, or partial hydrolysis is that either one of them is going to go. So what is not present in the mixture? So 1, 2, 3, 4, 5, 6. So one of them has OH, the other one has Br. So that is present. What about this one? Both of them have OH groups, so that is also present. This one is 1, 2, 3. On the third one, there is OH. And on the fourth one, there is also OH. This one is not present because the second one there's OH, and the third one there is OH. No, sorry, third one there's OH, and on the fourth one there is OH. So you're not going to have that because the OH is either going to be on the second one or the third one, or from the other side, it's going to be on the fourth one and the fifth one. So that one is not going to be present. The last one is going to be present. You see, it's the OH groups would either be at position 2 or 3 or at both positions, right? So over here, first carbon atom, like if I count it, it's first, second. The OH is on the third one and the other OH is on the fourth one. Is that clear? So it's the OH groups are not going to be on the third and fourth.
Yes, sir.
So which statement about mechanism of an SN1 reaction of a halogenoalkane is correct? So let's just quickly go through SN1, which is for tertiary halogenoalkanes, because they really like to, tertiary carbocations are like really stable. So the Cl breaks away first and carbocation is formed, and then the nucleophile, which can be OH -1, or it could be NH3 or Cn-1, they come in. So that's the simple SN1 mechanism for a tertiary halogenoalkane. So the question over here is which statement about the mechanism is correct? A nucleophile is substituted by an electrophile. No, that doesn't happen because there is substitution that is happening. Where's the chart? But both of them are kind of nucleophiles. Like Cl is a negative ion and OH is also a negative ion. So the OH ion is substituting the Cl ion, right? So anything that's attracted to positive charge, that's a nucleophile. So one nucleophile gets substituted by another nucleophile. So it's not, the first one is not true. One intermediate is formed from two reacting molecules. No, that doesn't happen. That happens in SN2 mechanism. In SN2 mechanism, the OH comes, bonds with it, and the Cl is also, when the Cl is also bonded to it. So you get one molecule, one intermediate from two different reactants. Over here, that's not happening. So the intermediate is stabilized by adjacent alkyl groups. That is true. The intermediate is charged, so that is also wrong. So what they mean by this is that tertiary carbocations are more stable. Why? Because carbocations with more alkyl chains, which are electron donating, are more stable due to lesser charge density, because there's so many electrons around it. The carbon has a very small positive charge, which is why the Cl is able to leave and take away the electrons that easily, because the carbocation has a very low charge density because of being surrounded by very large groups. Now 26 is structural isomerism and stereoisomerism should be considered when answering the question. Which one gives the greatest number of different alkenes when it is dehydrated? So when dehydration happens, the OH is lost and the H is lost from the neighboring carbon atom. So you're going to get a double bond on this side, or you're going to get a double bond on this side. So in this case, there are going to be two different alkenes. One would be this one, that the double bond is over here. The other one is going to be this one, right? And both of them would have cis and trans shapes. Both of them. Because if you look at the double bond over here, this carbon has two different groups and this carbon also has two different groups attached to it. So that's a total of 4 isomers. So I don't think anyone else would be able to make more alkenes. The first one, OH is lost and there's only one place where the double bond could be, and it's not going to form cis trans even because the carbon over here is bonded to 2 H's. This one, you put the double bond on this side or you put the double bond on this side, it's kind of the same thing. Or you could put the double bond over here as well. But in either case, like we're going to putting it over here and over here symmetrically, that is exactly the same. The other position could be the double bond over here, but that one would still not form cis trans because the carbon will have 2 H's. And this one again, you just have one double bond position. So that's so option B is the one which is going to make the greatest number of alkenes. Okay, is that clear as well? Okay.
Sir, in B, how is it cis trans? Can you repeat that part?
So for that, I'll just draw this. Like, clear enough. The double bond could be over here or it could be over here, right?
Yes, sir.
So let's say the double bond is over here. So I'm just going to draw that. It's 6 carbon atoms, right? And the double bond is on the over here, right? Right over here. So यहाँ पे देखो, if I draw the displayed formula, the two groups on this carbon atom are different. If I bring in the H over here as well, so this carbon atom as well, the two groups on this carbon atom are different. Is that clear? So it's going to have two different shapes. One would be cis, the other one would be trans. Is this clear?
Yes, sir.
I said 2,4-DNPH. What does 2,4-DNPH do? What it does is, okay, it's a test for identification of. It's a test for identification of ketones and aldehydes. Okay, that is what it does. 2,4-DNPH, carbonyl groups, and it does not produce a precipitate when warmed with filling solution. So that means it's not aldehyde. So basically, this means that it's a ketone. Why? Because aldehydes, they get oxidized with fillings. Aldehydes, they turn into carboxylic acid. So we know it's an aldehyde or a ketone, but it can't be an aldehyde. It then has to be a ketone. So compound key. So what could be the identity of compound Q? So it's a ketone. So it's going to be A. Is that clear?
Yes, sir.
That's the next one. Structural isomerism only, so no geometric, no stereo. A set of isomeric compounds with the molecular formula C5H10 all react in a 1:1 ratio with an excess of HCN by nucleophilic addition. So that means it's either an aldehyde or a ketone, because HCN NaCN catalyst they end up forming cyanohydrins, and that is only done by aldehydes or ketones. So this is an aldehyde or a ketone. How many isomeric compounds are in the set? So I'm looking for molecules that are aldehydes or ketones with the formula C5H10. So how many can you have? That's one would be the straight chain one, right? The double bond O is at the end. Then you can have, so this is going to take a long time. Then you can have double bond on the second one. Then what you can do is you can have the double bond on the third one. So those are your positional isomers. Then you can change the carbon chain. So double bond O is over here and the carbon chain is branched. Or you can change the position of the carbon chain. And that's where your double bond O is. Or what you can do is, that is nucleophilic addition. That's nucleophilic addition. Ketones and aldehydes, the mechanism is given right over here. That when you have nucleophilic addition, the CN-1 attacks this positive carbon atom in the carbonyl group and ends up bonding with it, and the oxygen becomes negatively charged, and H+1 then joins in from HCN. But moving on, the other portion is still, we still have a long way to go. I can change the position of the C double bond O. So if I do it, I will not be able to change the carbon branch. So that's it. The third one could be that the carbon chain could be further. It could be further. 5 carbon atoms could be branched further. And the only thing I can make it is an aldehyde. So I think that's about it. 1, 2, 3, 5, 6, and 7. So iska check karna padega. I'm getting 7. 4 carbon atoms, double bond O, change the position again, change the carbon branches, 4 carbon atoms, 1 over here. And these were the possible. I think there's one more possible. I think the double bond O could be at the other end as well. So the double bond O could be at this end as well. So the carbon branched versions could be these 4. Actually, this is already there. This one and this one are exactly the same. So I'm going to remove that. Still getting 7. Okay, but make sure you double check. Is this 7 or 8? I'm pretty sure it's 7. Or bus tickets. So let's continue tomorrow then. Okay. Let me mark this paper. तो कल फिर कंटिन्यू करते हैं इसी से. Okay, everyone. Take care.